In the previous lecture, we were discussing substitution methods for solving first order differential equations. Particularly, we discussed Bernoulli differential equation. Today, we are going to discuss exact ODEs of first order exact ODEs. In order to discuss exact ODEs, first we need to know what is the exact differential of a function, okay? Or simply the differential of a function. We need to know differential of a function. And then exact differential, and then we'll discuss exact first order ODEs. Now, what is a differential of a function? In Math 101, in calculus, you must have seen if y is equal to f of x is some continuous function defined on some open interval, then the differential is defined by dy is equal to f dash of x into dx. Now, what is this differential? It is basically a small change in x and small change, the corresponding small change in y. For example, now, what is the slope of a function? Slope of a function is the rate of change of a function. Okay. Now, the differential is what? Differential, in fact, if you have some function f of x, this is your function y is equal to f of x. Okay, and this is your x, and this is your x plus dx. Dx is some small change in x. This is your dx distance, maybe. Okay. Then, if this is a small change in x, what would be the corresponding small change in y? If this is the small change in x. So from here to here, you can see here, this is the dy, which is the corresponding change in the y coordinate. Okay, this is the dy. Now, what does it mean if we change x a little bit? How much change would occur in y? Okay, this is what dy basically gives us here. It's a we call it differential of this function. Now, this was the function of single variable. Y is a function of x. But what if we have a function of two independent variables? For example, let z is equal to f of xy. Here, now the function is a surface function. It's a function of two independent variables, x and y. Now, how do we take differential of a function which has two independent variables? We assume that this function is continuous and continuous on some domain D, okay, rectangular domain, which has some values where x varies times some values where y varies. So it is some kind of maybe 0 to a or a to b. From here, a to b. Here you have this thing, and y is from c to d, maybe this thing, okay? This to this. So this is your domain, rectangular domain. We call it D. The function is continuous on this rectangular domain, but the boundary will not be included. Okay. For the continuity, boundary may be included, but for the differentiability, we don't include boundary. I hope you know it. You must have studied in calculus. We also assume that f is continuous on the n, partial f by partial x and partial f by partial y. What is this? This is the first order partial derivatives of this function. We cannot take the normal derivatives. We call them, you can say, exact derivatives. So the partial derivative with respect to x and with respect to y at any point within this domain, it's also continuous. It exists, and these are continuous on D. Okay. Then the differential of this function, then the differential of f of x, y is defined by D. We take the D on both sides, just like we take the D here on this function. Dy is equal to derivative of this function times dx. Now here we have two independent variables. So how do we take differential dz is equal to is partial f over partial x times dx plus partial f over partial y dy. Okay. Now, in fact, this is the generalization of this differential. Here we had one single variable, independent variable. So that's why we take the exact derivative f dash of x. Now we have two independent variables here. We take the first derivative with respect to x plus first derivative with respect to y into small change in y. Here we had small change in x. So this is how we define differential of some function which involves two independent variables. Okay. And in short, and if we have a surface function whose values are equal to constant, for example, this one, or this one, if we have some function whose values are equal to constant, then its differential, we take the differential on the left hand side, the right hand side, we have a constant, the derivative with respect to x or y will be 0. So the differential will be partial f for partial x dx plus partial f of partial y is equal to 0. So times dy is equal to 0. This is how we define differential of that kind of function. F of x, y is equal to 0. Yeah, the value of surface is constant. Just like a circle, x square plus y square is equal to some 2, 5, or r square. Radius is a constant. So that is a surface, huh? It is changing. Circle, circle changing. Sphere, not circle, sphere. X square plus y square. Maybe you can say that. Plus z square is equal to some constant square. Kind of this, no? यहाँ पे sphere की यही equation होती है. In 3 dimension, if you take it, then if you take the half sphere, then what its value is constant, x square plus y square plus z square plus c square. It's uniformly changing x and y. You can say that at a constant rate. So this is the differential of the surface whose value is constant. Now, example. Let we have a function. Examples are given here in notes, maybe. If we have a function of x, y is equal to x square minus 1 times y. Okay, it is in fact, you can see, or this, if this is a function, okay, then how do we take the differential of this function? Df is what? It's partial f over partial x dx plus partial f over partial y dy. Okay. Now, partial derivative of this function with respect to x, what does it mean? What would be the partial derivative? 2x times y. Okay. Remember that while taking the partial derivative of this function with respect to x, we assume that y is constant. Okay. We assume that y is constant. So if y is constant, we can write it y here. Okay. We take only the derivative of the times dx plus, now while taking the derivative with respect to y, we assume x is constant. Okay. Now the derivative of y is 1, and this thing will remain same. So it becomes x squared minus 1 times dy. So this will be the differential of that function. Okay. If we had another example, maybe f of x y is equal to maybe x squared y plus 2y. Okay. Plus 7x plus 2. Now, the differential of x is df. We take the derivative, partial derivative with respect to x. Okay, partial derivative with respect to x. Here it is 2x, y remains same, plus here we don't have any x, so its derivative to y is assumed to be constant here. Here we have 0 plus 7 times x, it's 7 plus 2, 0. 2 is a constant. So this times dx plus, now we take again the derivative of that function with respect to y. So it becomes x squared, derivative of y is 1, plus 2y, derivative of y is 1. So we have 2 here. Here we have x. Here we have 0 because of the constant. So this is your differential of this function. Okay. I hope you get it. I hope you can find the partial derivatives. आप लोगों ने पहले पढ़ा होगा partial derivatives क्या होता है. So this is how we take the differential of a function. Now, when a function is said to be exact differential, okay, if we are given a function, differential of a function. So it is given. Can we find some function f of x y is equal to some constant? Okay, so that it gives us d of that function. D of that function. Do we have some function? It's this thing. So it is x squared minus 1 y. This is equal to differential of this function. So what is this? This is your function f of x y is equal to some constant. If we put it equal to maybe 0. Okay. Then the differential of this function is what? This is basically, or this this right hand side is what is the differential of some function f of x y is equal to c. We call that this is the exact differential. This is exact differential. Okay. For a given differential, if there exists some function so that we can write this differential in this form. Okay. We can find a function so that if we take the differential of this function, we obtain this thing. Okay. Then we call this thing to be an exact differential. Okay. If the function doesn't exist, then this differential will not be exact differential. Okay. I hope you get it. If you have any confusion, you can ask me.
So basically, sir, if we just take if the vector function is equal to a constant and we take its derivative, it's supposed to equal the exact derivative of like the function if it wasn't a constant or something.
Your voice is interrupting. Can you speak again a bit louder?
I was just saying that like an exact differential would be along the lines that if our function was equal to some constant and then we take its derivative, it's supposed to equal to the derivative of the function if it wasn't equal to a constant.
Yes, that's exactly like that.
Oh.
Or vice versa. If we are given some differential of this kind, okay, this you put it equal to 0. Now, okay. Now this is the differential of some function. Okay, here we have a function times dx functions times dx, and this is equal to 0. We call that this is exact differential if there exists some function f of x y is equal to c, so that if we take the differential of this function, we obtain this thing. Okay. Now let's here in these two examples, we already knew that there is some function. We started with the function, we arrive at this differential. Okay. What if we are not given the function? We are simply given the differential. For example, maybe 3x square y cube dx plus 3x cube y square dy is equal to 0. Now, we are given this differential. Can you think of a function? There is some method of verifying whether this is exact differential or not, but we haven't discussed that method. Can you judge whether there is some function whose differential is this thing? It's very easy. Three x square y cube 3x cube y square dy. Simply, I think we can write differential of x cube y cube is equal to some, sorry, is equal to 0. Okay. Okay. Now, can we write a function from here, f of x y is equal to x cube y cube? Now, if this is equal to 0, then this function must be equal to some constant while taking the differential. Okay. Now, this is the function, or this is the surface which we put equal to c. Now, if we take the differential of this function, okay, or this expression, we can arrive at this thing. Yes. So in this case, we call this equation to be an exact differential. Okay, this is exact differential. Why? Because there exists a function f of x y whose differential is defined by this, the left hand side of this equation, and we put this function is equal to c. So I hope you get it. If you have any question, you can ask me. So exact differentials also, they give us first order differential equations. Okay. Exact differentials, they give us first order differential equations. For example, if we have this differential, we can find a first order differential equation out of this. How can we find it? We just have to separate dy by dx. So we take dx on the other side. So we can write x square minus 1 dy is equal to 2xy dx with negative sign. Now you divide both sides by this thing. So we obtain, and then you divide dx here. So dy by dx is equal to negative 2xy divided by x here minus 1. So what is this? This is the first order differential equation. Okay, we can find a first order differential equation out of differential of some function. Okay, now if we are given the first order differential equation, we can write this thing in the form of a differential of some function, and then we'll go back and find that function, which will be the solution of this differential. I hope you get it. If you have any confusion, you can ask me. We have this function. We derive the differential of this function. We can find the first order differential equation. Okay. Now it's time to go back. If we have first order differential equation, we can write this differential equation in the form of a differential of a function, and then we have to find the function, original function f of x, y, which will be the solution of this differential equation. Okay, I hope you get it. Now, let's define this thing in a formal way. Okay. Now, if we have maybe m of x, y dx plus n of x, y dy equal to 0. This is what? This is a first order differential equation, because we can find a differential equation of first order out of this expression or out of this equation. Okay. Now, where the coefficient of dx is some function of xy, and the coefficient of dy is some function of xy. Okay. If the left hand side is the exact differential of some function, then we can find the solution of this differential equation. Okay. If the left hand side, if there exists some function f of xy is equal to c, then that will be the solution of this differential equation. Okay. Yes. यहाँ पे properly इसको define कर ले. A first order ODE of the form this is said to be an exact equation, if the expression on the left hand side is an exact differential. Okay. What does it mean? That is, there exists some function, that is, there exists some function f of x, y, such that d of f, okay, d of f is the left hand side of this equation. Okay, if there exists some function f of x, y whose differential is the left hand side, then f of x, y equal to c will be the solution of this differential equation. Okay, this is how it works. So then this differential equation of first order will be called exact ODE or exact equation simply. Okay, first order exact differential equation, or we simply say exact equation. Now, how do we know whether this function exists or not? How do we know? Because this function may not exist all the time for all the differentials. Okay. And is there any criteria to know whether such kind of function exists or not? Okay, there is some criteria. And what is that criteria? That criteria is defined in the form of a theorem. Let's discuss the statement of that theorem now. Maybe before discussing that criteria, let's have an example of this thing. Example I have given here. The first order ODE of this form, 2x minus 5y dx plus negative 5x plus 3y squared dy is equal to 0. Now this is first order ODE. Can you imagine, or can you find by some way, by guessing here, whether there exists some function whose differential is the left hand side of this equation? Now, you can see here that we have 2x, and here we had partial f over partial x. So this 2x comes from x squared. Okay, and 5y, it comes from 5xy, negative 5xy. Okay, because here we have negative. Here again, if we take the derivative of this thing respect to y, then this term will go to 0, and this term will give us what? Negative 5x. So this is okay. Now, where do this term come from? It comes from y cube. Okay, now I can judge that this differential, the left hand side of this equation, is the differential of this function. If we put it equal to c, because here we have 0, the derivative of c should be equal to 0. Okay, now this is your function whose differential is this equation. You can take the differential of this thing. The differential of x squared minus x 5y plus y cubed is equal to c. Okay, if we take the differential of this thing, we must obtain this thing. So this was a simple example. We can find it immediately. But what if we have maybe square here and 5xy cube here and many other terms, so that we cannot judge this function. We cannot guess this function. If we have some complicated forms here, complicated functions of x and y, then we won't be able to find some function whose differential is this thing. Okay? So there must be some criteria in order to check whether this first order differential equation is the exact differential equation or not. I hope you get it. If you have any question, you can ask me. We don't have this thing. So this was very simple. So this will be, sorry, this will be the solution of this differential equation. So if we have a differential equation of this form, what would be we require? We require to find some solution of this differential equation. And how do we find the solution? We still haven't discussed it. We have discussed what is up, what kind of this differential equation, what kind of solution it would have. And now let's discuss the criteria. Criteria is defined in a theorem in my notes. You can see that theorem. I'm going to tell you briefly what is the criteria and why is it. So if these functions, if these functions mxy and nxy, okay, If these functions m x y and n x y, if they are continuous on are continuous on some domain D, which is a closed rectangular domain. Rectangular domain means we have the values, all possible values of x. They are bounded by an interval. Their x is defined in some interval, y is defined in some interval. Okay, in two-dimensional functions, we always have a rectangular domain. In one-dimensional function, we have only single interval, which is defined in the form of a straight line. But in two dimension, we must have rectangular or triangular or square domains or some semi-infinite domains, kind of these things. If these functions m and n, they are continuous and their first order derivatives are also continuous, first order partial derivatives are also continuous on this domain D, then there exists a function, maybe या आप ये कह सकते हैं, then the left hand side of this equation will be an exact differential if the left hand side of this equation will be exact differential if partial, चलो next board पे define कर देते हैं उस तरफ so that you can see it properly. Let me define it on the other board. Then the equation that m of x y dx by n of x dy, then that equation is said to be exact equation if partial m over partial y, we take the derivative of m respect to y. It should be equal to partial n by partial x. If this holds, then we say that this equation, maybe we call that equation 1. Then the left hand side of equation 1. Equation 1 is what? It is m of x y dx plus n of x y dy. Okay, this is equal to 0. This is your equation 1. Then the left hand side of equation 1 is exact. If the left hand side is exact differential, then furthermore, there exists a function f of x y, such that df is equal to what? M of x y dx plus n of x y dy. Okay, the left hand side of this equation will be the differential of that function f of x. If this is so, what does it mean? It means f of x y is equal to c is the solution of 1. Okay. Now the question is, if this is true, then we know that we will be sure that there exists some function f of x y whose differential is the left hand side of this equation. how do we know that function? How to find that function? Okay. This criteria doesn't tell us how to find that. This only gives us that the left-hand side is exact differential. If it is exact differential, then the next question is how to find that function f of x, y, whose differential is this equation. Now, let's discuss how to find this function. Still, we haven't discussed how to find this function. Okay? If you have any confusion, if you have any question, you can ask me. We cannot integrate it because here you have a function m of x, y. Okay? Here you have dx. If you integrate this thing with respect to x, what would happen with y? Y is a function of x. Y is a function of x. You cannot integrate it by simply assuming it constant. If you can separate the variables here, x and y, then it is possible. Then you integrate by using separation of variables math. If you cannot separate, then you cannot integrate the mixture of both variables x and y, because these two are independent variables here. So how to find this function f now? This is your equation 2, maybe. And if this is your function f of xy, or this is your expression f of xy is equal to 0, then we know also that the differential of f is what? It is partial f over partial x dx plus partial f over partial y dy. Okay, you call it equation 3. If we compare 2 and 3, what do we get? Comparing 2 and 3. If we compare 2 and 3, we get two equations. Partial f over partial x is equal to m of x. M of x y, this one, and partial f over partial y is equal to n of x y. Okay. We call it equation A maybe, and we call it equation B. Okay. Now these are the expressions which will help us to find the function f. Okay. Either we start with this or we start with this. Okay. Because these expressions now, they involve f. We didn't have f here. Okay, because we can say that there is some function f of x, y, whose differential is the left-hand side. Now, after comparing 2 and 3, we have these expressions. Now we know that partial f over partial x is equal to this thing, and partial f over partial y is equal to this thing. Now here is, we have some function f. Now we can integrate. And this differentiation is with respect to x only. Here we had treated y as a constant. Okay. Now, if we integrate this thing with respect to x only, and we integrate this thing with respect to x only by assuming y as a constant, that is true now. Okay. Either we start with this thing or this thing. Okay, you can start with either of these two equations. Now let me start with the first equation. Maybe if we have partial f over partial x, and integrating with respect to x, we get what? Here we get f of xy. Okay, because the left hand side integral and derivative with respect to x will be canceled out, and we get here integral of m of x y dx. Okay. We always write here what? A constant of integration plus a constant of integration, constant of integration. Now, if we think here carefully, while we take the derivatives, if we take the derivative of this function, for example, if we have some function, maybe f of x y is equal to x square y plus 2y plus 3. Okay. Or maybe here you have x cubed. Oh, sorry, y cubed. Now, if you take the derivative of f with respect to x, what would you do? You assume y to be constant, y cubed constant. You take the derivative of this thing, which is 2x. Now, here you have only y. What would happen here? It will become 0. And what would happen with this constant? It will again become 0. Now, what constant of integration should we define here appropriately, which take into account these things? It's different from the simple constant of integration. It should be different from simple constant of integration, which you have already discussed in calculus. So what kind of constant of integration should we define here?
A function of y.
Yes, it should be some function of y. Okay. Now this whole thing, which involves y only and constant only, we can say it that this is some function of y, maybe g of y. Okay. So here the constant of integration, appropriate constant of integration should be some function g of y, not only the simple c, the simple constant of integration. It should not be like that. So here we have sorry, some function of y, okay, as a constant of integration. Now, this function is unknown to us. This function is unknown to us in this derivative. Okay, how to find this function now? Now, after integrating here with respect to x only, we take the derivative y as a constant. We can find the integration here. After finding the integration, we find the function of xy, which was required. We assume that the integration of this thing is some m bar of xy. Okay, this is the integral of this whole thing plus some function of y. Okay, now we know the function which was required, but there is still some unknown thing here. Still, we do not know g of y. Okay, this thing is unknown here, which need to be computed or determined. Okay, it need to be found. How to find it now? We use the second equation. If we started with the equation A, we arrive at this thing. We call it A, B equation, maybe C. Okay. In order to find this unknown function of y, we use equation B now. Okay. What is equation B? Using equation B. What is equation B? Partial f over partial y is equal to n of xy. Okay. How do we use it? Now we know the function f. We know it. We know it now. We take the partial derivative of f here. Okay. We take the partial derivative of c. Okay. What would be the partial derivative of c? It would be partial m bar over partial y, which can be easily computed, plus derivative of this function. Okay, it's a simple function of y. So we can write here g dash of y because it's a single variable function. We don't need to write here partial derivative. We simply write g dash of y, which is a dg by dy. And this is equal to what? This is equal to n of xy. Now, n of xy is known. Partial m bar over partial y is known. From here, we can find g dash of y, which is equal to n of xy. It is known from the equation, from the given equation, minus partial m bar over partial y. This is your g dash of y. But what you require here, you require g of y. Now, here again, you integrate with respect to y only. Okay, integrating with respect to y. What do we get? We get g of y. Okay, which would be some function of xy. Okay, which would be some function of, it should be some function of y only. It should be some function of y only. Okay, so function of y, you can say here. Function of y you obtain here plus a constant of integration c. Because it is a function of y only, so you don't need to worry about now. You can write c as a constant of integration. Now, once you get the expression of g of y, you plug it here in this equation c, you get the solution. Okay. Now, if you have any question, if you have any confusion, you can ask me. We'll do a couple of examples of this thing. That is complicated, not like that. ठीक है, function of 3 variables का exact, उसका कोई अभी तो कोई criteria नहीं है कि how do we know whether this is exact or not, exact equation or not. This criteria only exists for a function of 2 independent variables. ठीक है? If we have 3 variables, what would be the criteria? We still do not know. What is criteria here? The criteria is partial m over partial y, it should be equal to partial n over partial x. This is the criteria. If this is true, first of all, we need to check whether this is true or not. If this is true, then we move forward. Otherwise, we stop here. If this is not true, we stop here. We say that this is not exact differential equation. Okay, we don't move further for the solution. I hope you get it. If you have any confusion, if you have any question, you can ask. Now, we can start with the equation B as well. Partial f over partial y. In that case, we integrate with respect to y, and we get here a constant of integration with respect to x. That would be your g of x, maybe h of x or some other function, h of x. In that case, you equation after getting this, you use the equation A. Okay, partial f of partial x equal to m. You take the derivative of that function with respect to x and put it equal to m, and then you can find the function of x. Okay, in a similar way, everything will be changed. I hope you get it. If you have any confusion, if you have any question, you can ask me. Otherwise, we are going to do an example of this thing. Example. Sorry. Show that following ODE is an exact equation or exact first order. Exact equation. What is the equation? 2xy dx plus x square minus 1 dy. We had defined this thing previously, I think. You can prove this one. Second example, maybe you can take some other thing. This and this. There are some more examples. E to the power 2y minus y cosine of x y dx plus 2x e to the power 2y minus x cosine of x y plus 2y dy equal to 0. Another example, this thing dy by dx is equal to x y square minus cosine of x sine of x whole divided by y times 1 minus x squared. Okay. Now, we need to show that these equations are exact. Okay. What do we need to do? Here, partial m over partial y is what? For the equation 1, we take partial derivative with respect to y. So it should be 2x. Okay, 2x. And what is partial n over partial x? It is यहाँ पे y भी आना चाहिए, यहाँ पे y भी है. So it is again 2x. So it is partial n over partial x. नहीं, y नहीं है यहाँ पे. Y नहीं है. Okay. What is the derivative of this thing? It is n. Partial n over partial x is 2x. So partial n over partial y is equal to partial n over partial x. So this equation is exact equation, exact first order ODEs. Now here, for this equation, partial m over partial y means this is your m. We take its derivative with respect to y. What would be the derivative of this thing with respect to y? E power 2y. What is its derivative? It's e power 2y into y. No, e power 2y into 2. Minus, you have y cosine of xy. Use product rule here. Okay. So first you take the derivative of y1. You write cosine of xy as it, and then again minus y. Derivative of cosine is minus sign, which comes here positive sine of xy times the derivative of angle with respect to y is x. So this is your partial n over partial y. Now you again find partial n over partial x. Okay. So this is your n. You find derivative with respect to x. So here you have 2x e power 2y. Its derivative with respect to y, sorry, x is 2 times e to the power 2y minus its derivative here with respect to x. You use the product rule. It is 1 cosine of xy plus x as it sine of xy times y. So are these two equal? This one and this one? They are equal because this term will be 0 while taking partial derivative with respect to x. So partial m over partial y is equal to partial n over partial x. Therefore, this second equation, this is exact equation. Okay. Now you can see that this is neither separable nor linear, nor homogeneous, nor we cannot use substitution here. All the previous methods which we have already discussed in order to solve first order differential equation, they all fail to solve this differential equation. Okay. So now we have another method for solving differential equations. All the previous methods which we have discussed, they do not help us to find the solution of this differential equation. But we can now have another method that we can check whether this left-hand side expression is exact differential or not. If this is exact differential, then we can find the solution in this way by using this technique. I hope you get it. If you have any question, you can ask. Similarly, this equation, you need to write it first in this form or in this form. You just cross multiply, and then you bring the other side on the left-hand side. You can have an equation of this form. And then you can try this technique, whether this differential equation has solution or not. Because all the previous techniques which you have discussed, they fail to solve this differential equation. This is non-linear differential equation because x, y square, cos x, sin x, we cannot separate y or x from here. If we cannot separate, this is neither linear, we cannot use any substitution, this is not homogeneous. So all the previous techniques, they fail to solve this differential equation. So now we can try another technique, whether this is exact differential equation or not. If it is exact, then we can solve it. Let's try the solution of some equation. If you tell me, try the solution of this one or this one, second or third. Let me solve the second one. Yes. Now the criteria has been satisfied. The equation is exact. So there must exact some function f of x, y, whose differential is the left-hand side of that equation. Okay, now we are sure. Okay. Then we can start with partial f of partial x is equal to m of x, y. Okay. That equation A, remember that equation? You have to remember this, that partial f of partial x is equal to m. Now what is m here? In this equation, m is e raised power 2y minus y cosine of xy. So this is your e raised power 2y minus x, y cosine of xy. Okay, this is your m. Let me see it again. Yes. Now you integrate it with respect to x. Okay, integrating with respect to x, you get f of x, y is equal to integral e raised power 2y minus y cosine of xy times dx. Okay, plus a constant of integration, which is g of y. Okay. Now, here you assume y to be constant. Okay, because you had partial derivative. You assumed y to be a constant. Here, this is constant. Its integral is what? 2y times x, because we have 1 here. This whole thing is constant. The derivative of, if we have a constant, its integral is x. Minus y is a constant, integral of cosine of xy. Here is x. So its integral is what? Sine of xy divided by y, because y is some constant. Okay? Its integral is this thing, plus the same g of y. So you obtain f of xy here. Okay? So this y will be cancelled with this y. Okay? Now, if you have f of xy is equal to this thing, now you use the second equation, which is partial f over partial y you put it equal to n of xy. Okay. Now you take the partial derivative of this thing with respect to x. Sorry, y. What would be the partial derivative of this thing with respect to y? It is x e raised to power 2y into 2. Okay. And then the derivative of this thing with respect to y, which is cosine of xy times x and plus g dash of y. Okay. And you put it equal to n of xy. N of xy is given in the equation. This thing, this is your n of xy. Okay. You put it equal to this expression, which is 2x e raised to power 2y minus x cosine of xy and plus 2y plus 2y here. Okay. Plus 2y. Okay. Now you can see that this term will be cancelled with this term will be cancelled with this term. You are left only with g dash of y is equal to plus 2y equal to plus equal to 2y. Now you can see that this is a function of y only. Okay, there's no x involved here. Technically, there should not be any x because we had assumed that it's a function of y only. Okay, so x terms should be cancelled always. The terms which involve x, they should be cancelled always. We should obtain a function of y only here. Now integrating this thing, integrating with respect to y only, what do we get? G of y is equal to 2 times y squared by 2 plus some constant of integration. Okay, you don't need to write this constant. Why? Because still you write it. So g of y is y squared plus c. So this is your g of y, which was unknown here in this function. Now, by putting the value of g of y here, we can finally obtain x to y minus sine of xy plus y squared plus c. This is your function whose exact differential or whose differential is that equation. The differential of this function is this equation. Okay. Now, what would be the solution of this differential equation? You put it equal to c, some constant, and this constant will go there and make it another constant. Okay. So the solution of this differential equation is what? It is x e raised to power 2y minus sine of xy plus y squared is equal to some constant c, maybe c naught. Okay, so this will be the solution of this differential equation, not this one, this one. I hope you get it. If you have any question, you can ask me. Now I give you 5 minutes to solve. Where is that thing on? Yes, this one. I give you 5 minutes to solve this equation. Okay, try this one on paper, and if you find any difficulty, if you find any problem, you can discuss with me. I hope you have already written this equation. Try to solve it and tell me your answer. I'll give you the correct answer later on. If you have any confusion, you can ask me any question. You guys don't have any question? Don't have any confusion? Have you solved that exercise? Anyone? Can you tell me the answer?
Yes, sir.
G, yes.
Minus 1 over 4 cos 2x minus x square y square by 2 plus y square by 2.
Let me write the answer for you guys so that you can compare it with your one. So answer to this exercise is 1 by 2 x square minus 1 y square plus 1 by 2. In fact, you can cancel out 2 throughout. Cosine square x plus c equal to c. Maybe equal to c. This should be your answer. If this is your answer, then this is correct. Otherwise, you might have done some mistake while doing the integration or while manipulating things here. So I hope you can do it later on if your answer is not correct. If your answer is correct, then it's okay. That's all for today. In the next lecture, we shall discuss the same non-exact equations and some other topics. If you have any confusion, if you have any question, you can ask me one final time. No? Okay, then see you next week, inshallah. Take care.